Hi, and welcome back to Glassboxed, writing automated RSpec tests. Today we're going to have a look at collections. We will look at what a collection is, why you would need to consider using collections, and how you would use collections and write tests around it. So what is a collection? Well, a collection is basically a group of web elements all located together as part of the same list, if you will. It allows us to look at multiple web elements at the same time, look through each and every single one of them and act on them. So for instance, let's just say we wanted to get this home link as a single web element. We may instead want to, for some reason, get all 4 of these links in one go and treat all 4 of these links as a single web element and act on each one of them individually. We may want to instead get all the links on a page and then look for the link we want. You might want to get all the text on a page and then do different things depending on what text you find in your list. You can also, if you like, have, say, various input fields, and instead of having to find an input field individually and then do something to it, you might want to get all the input fields in one go and then send data in one go and have all the necessary information inserted in all the fields again in one go. So there are various cases where you want to get a lot of elements in one go. Sometimes you really don't have a choice, sometimes you might have to. For instance, let's just say these links, which at the moment, if we just inspect them really quickly, we know that they have IDs and name attributes, but sometimes there might not be anything there, and the only thing you might have to go on is the tag name. And let's just say you don't want to use CSS selector or XBAR. Sometimes you don't really have these attributes such as ID or name. You might only be eligible to only select the tag because that's the only thing in there. So for instance, if we just looked at this H1 tag, this only has H1, there's nothing else in this particular tag. It certainly has a lot of child information, but this tag itself has nothing. So there are various cases where you might be restricted to what you can do, and getting it as a collection might be a sensible choice in order to get to the element you want. And that's effectively what we're going to try and do today. What we'll do is we'll try and effectively grab something of a page in a collection and then look through that collection, and then when we find the thing we're looking for, we'll act on it. So the scenario that I've picked, and it's a really basic scenario, all I'm going to do is I'm going to navigate to this page and I'm going to try and grab all the anchor tag links. So to those who don't know what anchor tags are, anything that's effectively a link which is defined inside an anchor tag. So this is one, this is another one, this is another one. I'm going to try and grab all of them in one go, and then I'm going to look through them, and then I'm going to do something based on what I find. So let's see how we'd write that in a test. So here I have a really basic RSpec test, nothing different than what we usually do. An empty Firefox browser that opens, navigates to the zoo site, and then in the after method we just quit the browser, so it closes. We quit the driver, so it closes the browser. So what are we trying to do? Well, let's write it out in comment form first. So the first thing we're trying to do is effectively grab or get all the links on the page. Then what we would want to do is look through all the links, and as we're looking, we want to do something as we find the link we are looking for. So how do you do this? How do you effectively break effectively this problem of getting everything in one go and then looking through things? Well, we'll break it down into smaller problems. So we've already identified what the 3 problems are. First, we need to find a way to get everything on the page. Then we need to find a way to look through everything we found, or rather everything we just grabbed from the page. And then we need to find a way of doing something once we've found what we're looking for. So the way we're going to do that is we need to use a find element method that driver provides us with. So we've already used driver dot find element, where we find something by something. So let's just say for the moment by some locator, and then we provide a value, and that's it. Well, driver actually provides us with two find elements. So this one, which we've been using, has always returned either 0 or 1 element. So from this you either get a single element. If there happen to be multiple elements, it selects the first one, or it returns nothing at all. But there is another one called find elements. What this does is this returns 0 or more results. So you'll either return nothing because there's nothing on the page, or you'll return 1 or more than 1. So another way to think of it is driver.findElements will either give you a result of 0 elements or nth elements. So find elements is what we would use to look for multiple elements at the same time. So I said that we want to get all the links on the page. Well, the difficult thing about all the links is that although they're all links, they all have common attributes, which is fantastic, but all the values for those attributes, almost all of them are completely different. So that's not very helpful. But the one thing that they all have in common is that they're all inside anchor tags. So they're all inside the same type of tag. So that means we can search by tag, and the tag we want to search by is A. So when we run this, what this will do is this will find everything on the page by tag of type A, and you will find either 0 or more than 0. So we know at the minimum that there is at least home, adoption, about, contact, and this terms one here as well. So if we have a quick look, yes, so that's inside an anchor tag. So we're expecting potentially up to 5 elements to be stored, or rather returned to us as a result of running this. So this is how we effectively get 0 or more elements at the same time. So the next thing we need to do is we need to now somehow look through all of this element one by one and then do something. So obviously the do part comes afterward. For the moment, our problem is somehow trying to look through all of these elements first, and the way we do it is by using loops. So I hope you understand what loops are, but for those who aren't, I'll give a really brief explanation. A loop allows you to look through a list of items, usually one by one, and you continue to look through your list of items using that loop until you get to the very end of your list. And when you look through each item, it allows you to act on them individually, one at a time. So what we'll do is, now that we have a list of elements, we're going to use a loop to look through each one of those lists, assuming we actually had 1 or more returned. So let's do that here. So RSpec provides a couple of ways to write loops. We'll be looking at 2. We'll be using what's called the for each loop, and we'll also mimic the exact same behavior using a traditional for loop. So let's look at the for loop first. So when we say a for loop, to write it out, you say pretty much for, and you give a value, which is effectively an incrementable value, which allows you to better identify which item or which number of item you're looking at your full list of items. Then you say in, and here you give the name of the list you're looking at, and then you end it. So this name of list, where do we get this name of list? Well, this is our list, but we need to somehow identify this in here. So the way we do this is, when you have a find elements and you want to assign this information to some kind of variable, you can quite easily just give a name here. This tag list now contains your full list of web elements where the tag is of type A or anchor. And now that we've effectively saved all of these web elements in this variable we've just created called a tag list, we can now use this information in here. So now here what we're saying is for I in tag list. This basically means I being the element you're looking at that point in time in tag list. And we can now take this further. So all I'm going to do is, just to make things a little bit simple, I'm just going to print out the contents of the list. So the way we do that is you put in quotations and you just print out the value of I inside your tag list. So if we just say value of I is, and in here we use a notation to say that we're looking at this incremented value for this list of objects. And the way we do it is we say hash, and then we give curly braces, and in here we say I, which is effectively the nth element you're looking at in this list, followed by whatever you're trying to search. So in this case I'm just trying to get the text, if you like. So what does this do? Well, what this does is this, as explained, will look through all the objects in tag list, and for each object, or rather for each incremented object, it will print out the value of text. So before we do anything else, let's quickly run this, because I think by seeing some result it will probably make a little bit more sense as to what this loop is actually doing. So let's run this and see what happens. Oh, sorry, looks like there's an error. It's because I've said tag when I should have said tag name. Right, okay, let's just run this again. Well, look at this. So it's actually found all of our links, which is fantastic. It's found home, it's found adoption, about, contact, and terms. So by using this driver.findElements, not single, plural, it's found multiple web elements and it's stored all that information in one variable, which is effectively an array in disguise. And then we use a for loop to look through each one of these objects in our tag list and then print out the text. So I apologize if my explanation of this isn't exactly very clear. It is a bit iffy to describe to those who don't understand loops. So there's a far easier way I can do it. I can just print out random numbers, and that would probably make more sense. But there's a reason why I talked about this for loop first and not the for each loop, because the for each loop traditionally just makes it just that little bit more sense. Yeah, traditional is probably a strong word, because for each loops are relatively new compared to for loops. But anyway, let's try and replicate the same behavior, by this time using a for each loop. So to use a for each loop, the way we do is we give the name of the list we're trying to look through, so in this case it's tag list, and then we say each followed by do, and then here we give some variable name. So in this case I'm just going to say item. So this is what's called a for each loop. What this does is this takes an array and then we say dot each, and then we say do, and what this means effectively is look through each of the items in tag list. So we're basically saying this isn't exactly in plain English, if you like, but this makes a little bit more sense than that, in that this almost spells out that we want to look through each item in tag list, and then we're going to do the same thing again. We're just going to print some information, and we're going to try and print the text value of all the items we found. And let's print a slightly prefix string value, just so we can distinguish between the prints in our for loop and the prints in our for each loop. Let's just say for each value for item is, and here, because we're looking at item, we just say item dot text. So this item is effectively the item we're looking at that list for whichever item we happen to be looking at that point in time. So just to make sure it's all working, let's just quickly run this and see what happens. Alright, so if you have a look, this was the value printed using our for loop, and these values were printing using our for each loop. So they printed exactly the same values, or another way to think of it is, because we're still using the same list object, we were able to access each and every single one of our items in our list. So to me personally, using a for each loop is just much more easier to understand and interpret as opposed to using a for loop. We've now effectively covered how to look through all the links, or if we're a little bit more generalized about it, how to look through a number of items in a list we generate. So the last thing we said we would do is, once we've found something we're looking for, we want to do something. Since we're looking through loops, I'll just work on the for each loop. What I want to do is, when I find the home link, what I want to do is I want to still continue looking at the list. But when I find the about link, what I would like to do is print out some other information, a random string value that I'll provide. And finally, when I find the contact link, I want to break the loop. So I want to stop looking through the remaining items and just stop. So that's what I want to do. To achieve this, I need to use what's called a conditional statement. And in this case, I'll be using an if statement. So again, I hope you're familiar with if statements, but really briefly, an if statement is effectively an expression that evaluates to a Boolean result. Either whatever expression you provided is true or is false. If it's true, we go inside the if statement and we perform whatever logic is inside it. If it's false, then the if statement is completely ignored. So what I'm going to say is, if item text equals home, and remember we need to end it with an end, then what I said we would do is we'd just continue to look through the list. And to continue looking through a list, in Ruby we use the keyword next. What next basically does is it jumps back to the top of the list and continues again. So if you like, if I put in a puts here for instance, and if I punch in something like this line should not print out, then it shouldn't, because what the next does is it forces whatever item we're looking at that point in time, and to stop, go back to the top of the list and continue to look from the second item. So this line should theoretically never really print out. So that's how we continue to look through a list without performing any further logic on it. The next thing we said we'd do is, when we find the contact link, when we find the about link, we'd print some text out. So we can replicate that quite easily by just copy pasting that. We'll just say about here, and we'll take out the next, and let's just say found about. The last thing we said we'd do is, when we find the contact link, we want to terminate the loop. We don't want to look through the remainder loops. So again, we can do that quite easily by just saying contact here, and in here, as opposed to putting in a next, which basically stops the current iteration and goes back to the top and looks through this next iteration or the next item in the list, if we use the keyword break, what that does is that breaks the full iteration and forces you to jump out of the loop entirely. So when we rerun this test, when we get these values, these particular values here, what should happen is, when we get home, the next line of text should still be this line here, because this line shouldn't print. When we get to the about, we should also have an additional line with this printed, and when we get to contact, then this line shouldn't print because we've already terminated the loop. So let's run this and see what happens. Right, so it looks like we actually got the result we expected. So it printed out home, but it didn't print this out, which is proof that when we hit this line of code, it broke the current iteration in the loop and went back to the top and looked, or started to look through the next item. It then printed out adoption. We weren't obviously acting on adoption. When it came to about, it also printed out this additional line of text, proving that it found about, and it then began looking at the logic inside this if statement. And when it went to contact, it broke the loop. So in essence, it didn't print out these terms because we told it to break. Now there is a good reason why I've shown you how to continue looking through a loop, how to do some logics when we found something without continuing or breaking, and how to break something. And the reason is this: there will be times when you've found something and you want to act on it, do some logic, but you don't want to look through the remainder of the loop because there's no need, it's a waste of time. So for instance, if we looked at our contact page, let's just say we were getting all of these elements, these input fields, and we found the first one and we inputted some information. There's no need to look through the second, third or fourth one because we've already acted on what you've wanted to do. So you can just put in a next. That would effectively ignore the rest of the loop and it would continue. So this is a good candidate for using continues. Naturally, the logic would apply to almost anything. If you find something you want to act on it, act on it. The break loop is also a really important concept to grasp. For instance, let's just say we got all of these links. We got the home, adoption, about and contact link, and we wanted to click on adoption, and we employed this for each concept. This is how we wanted to do it for any particular reason. When we click on adoption and the click has been made, because we haven't terminated the loop will still try to look through about and contact. But because you've clicked on adoption and it's gone to a new page and a new instance of everything has loaded, it will actually throw a null pointer because about and contact for that page, which now doesn't exist, will not exist. So you'll get null pointers. And the way to avoid that is to break out of the loop, i.e. you've found what you want, you've done what you want, now you want to break out the loop. Breaking out of the loop, continuing inside a loop, and performing some logic in a loop when working with collections is an important concept to understand and grasp and use correctly because it reduces errors. And that's it for this video, folks. If you enjoy my video and find they bring you some new knowledge or insight into writing WebDriver RSpec tests, then please subscribe and rate. If you have any questions or video suggestions, then please leave a comment below. Many thanks for watching. Until next time, ciao.